Good afternoon, everyone. Thank you for joining us today for our newest webinar installment, One Water Perspectives. We are really excited to be hearing from thought leaders, regional managers, policymakers, and practitioners from across the country, and are eager to learn more about their local accomplishments, lessons learned, and activities currently underway in their region. We are kicking off the series today with a presentation from Dr. Glen Daigger, member of the UN External Advisory Committee, and just delighted he could join us this afternoon. Please be sure to tune in next week when we set sail for southeastern Florida and hear from Dr. Doug Yoder, Deputy Director of the Miami-Dade Water and Sewer Department. For those of you that are new to the webinar series, I just want to cover a quick few housekeeping items. First, we are recording each webinar and posting them to our YouTube channel, and a link will be added to the UN webinar webpage and disseminated as soon as it's available. Second, all participants have entered the webinar muted, so please enter your questions in the chat queue and we will address them at the end of Dr. Daigger's presentation. Barring any technical difficulties, I will try to unmute you at the end of the presentation so you can ask your question directly to Dr. Daigger. Doesn't always work though, so there may be a few challenges along the way. And with that, I am excited to introduce our presenter for today, Dr. Glen Daigger, Professor of Engineering Practice at the University of Michigan and President and Founder of One Water Solutions, LLC, a water engineering and innovation firm. He previously served as Senior Vice President and Chief Technology Officer for CH2M Hill, where he was employed for 35 years, as well as Professor and Chair of Environmental Systems Engineering at Clemson University. He has advised many global communities from New York to LA and San Francisco to Singapore. Deeply involved in professional activities, Dr. Daigger is a past president of the International Water Association, the recipient of numerous awards and distinguished member of ASCE, IWA, and a Water Environment Federation Fellow. And with that, we're going to let Dr. Daigger take over. I'm going to mute myself, and I know we can hear you loud and clear, so take it away, Glenn.
Well, thank you, Sarah. It's really a pleasure and a privilege to be speaking to you. And before we get started, I might make a comment about the title here, Reinventing Urban Water. So as I think many of you know, that the current approaches that we use to manage urban water, when I use the term water, I don't restrict it. It's the various forms of water in the urban setting, which is also connected to the broader broader watershed. But the way we do things now has been actually reinvented in about the same way, many times, not over centuries, but millennia. When you really think about it, the current version was really invented in roughly the middle of the 19th century in cities in Europe, and then lagging that just a little bit in the US. The first step being bringing fresh water in significant quantities into the urban area versus using local water supplies, that being a great boon to public health. That single step has saved, I don't know that there's a count, but it's in the hundreds of millions, if not more, of people's lives. It also is, it is where human beings invented sewage. Human beings actually invented sewage because, when we brought all that water in and started using it, then the question was, now how do we manage our wastes in the context? And it wasn't that they were unmanaged before, they were managed, but the idea of waterborne sewage was developed and has been widely applied. So, we actually did things differently before that in essentially every urban area in the European and American context. So we're not stuck doing what we're doing now. So as I kind of introduce the topic, reinventing is taking a look at, given that what we've done in the past was done for good and valid reasons and was a lifesaver to so many, is it what fits us in the future? So that's where this presentation starts off. So, and I posit that we actually need to think about the situation that we have not in the past that uh, caused us to develop the systems that we have. And I'd say here the second half of the 20th century, but it was really formulated again in the beginning in the middle of the 19th century and carrying forward. But I think all of us as water professionals know that while we're living in 2018, we need to be thinking well into the future. We need to, as we think about water, live in the virtual reality in our imaginations of what the situation is going to be, not only in the middle of the 21st century, but really the second half of the 21st century, simply because of the long life of the infrastructure that we put in place, as well as the institutions and so forth. So you've read this slide as I've been talking, but I think you get the point of the differences between the past and the future, and it's the future, the middle to the second half of this century that we need to be thinking about in terms of the water decisions that we make today. And these things are changing. So we often talk about population growth, but quite frankly, water is driven by economic growth. Just look at China as an example in terms of, population hasn't grown that much over the last few decades, but the economy has grown tremendously, and that has dramatically changed the water situation there. And growth, if you look at the middle GDP, but almost anything, things grow exponentially, not in the linear terms that we often think. And of course, the other situation that we're dealing with is that the human economy for millennia, but certainly you start with the beginning of the Industrial Revolution, has been based on resource abstraction and use, the take, make, waste idea, which is, and you see the Rockstrom analysis where we're actually, we will not forever, but we are trying today to overuse the renewable resources of the planet. This is practical also. The middle bottom is really showing, and I'll come back and mention this again, but a sign of emerging limitation is when you start to get price instability of commodities, and that kind of starting in the 90s, that began to occur. So this has not only moral and ethical, but practical consequences. And then we put climate change on top of that. So the future will be distinctly different than the past. That's the point here. So our opportunity here is to reinvent our profession. And what I'm listing here, and again, I'm not going to read through each and every one of these, but looking at how we have approached many components of managing water in the urban setting, and how they can, and I believe how they need to be different in the future. And the only way the future is going to be different is if we start doing things differently today. Our infrastructure is put in place over an extended period of time, and with a long life. So unless we are envisioning that future, the middle to the second half of the 21st century, and putting in place pieces today and transitioning our systems to that, we won't be able to realize this future. So what I'm going to talk about is first of all the components of what this future can be. I don't have all the answers, but I'm thankful that I see us moving in this direction. We have places like UN that are helping to generate the knowledge and so forth. But then secondly, I want to talk about how we make the transition, which to me is the topic that my thought process has been tumbling to more and more. We increasingly know what to do. How are we going to get in place? So when I talk to water professionals, and one of the things I've learned about human beings is we can remember a few things. There's a reason that telephone numbers are chunked into bits of 3 and 4. It's so we can remember it. So I tell folks that from my perspective, we only need to do 3 things. They're pretty big things, but they're only 3 things. So any of us can remember them and be working on them. And I'm going to talk through these 3 elements here over the next few minutes. So the first is fundamentally change our approach to water management to avoid stress. That's a pretty big thing. Let's just change how we manage water, and with the focus on avoiding stress. Now, one of the things about water is that usually the situations that we're dealing with is either don't have enough water or we have too much. Rarely are we right in that perfect point where we're just right. What is interesting is that the concept and the approach to dealing with that, although physically different, is conceptually the same in either instance. We're increasingly admitting to ourselves that there's a lot we don't know, and I will actually come back to talk about this as I talk about the changes in professional practice. But rather than finding an optimum condition, an optimum system, which is only optimum if we know what the future condition is, what we're looking at are assembling components of a system in a portfolio that each component performs well under different circumstances. For water supply, it was really the Australians that pulled this together, not only from a conceptual but from a practical perspective, in talking about the water supply portfolio. So you are reading on the left-hand side the components of this, but these are elements that work well under different conditions. When it's raining and if you have the infrastructure in place, then using that natural water is oftentimes a very cost-effective and can be environmentally desirable approach. But when it's not raining, what are you going to do? Reclamation, efficiency, things like this, desalination, in my mind, is a last resort, but is part of the portfolio. So components that work well over a range of conditions. From a flooding perspective, although it's not expressed in the same fashion, it's the same idea. We've come to realize that dikes by themselves won't save us. That we have to put certainly conventional measures in terms of drainage and dikes and levees and stormwater systems, but they need to be supplemented by other components, because we can't build the dikes big enough. We can't build the pipes big enough to handle. And in fact, the Dutch were the first to talk about this, but the idea of room for the river. The Dutch don't think about designing to a given recurrence frequency. They think about, yes, we're going to physically protect to a certain level, but after that, we're going to think about what gets flooded and managing from that perspective. Fundamentally the same idea. Now, changing the way we approach something, part of it is changing how we think. So I want to give you an example of some of the biases that we have. So if you look at water supply and wastewater, you see the traditional approach. Water supply is where we're going to get more water, and wastewater is where we're going to discharge to. What if we first asked, where and how are we going to reuse? We would get different answers depending on the questions that we ask. So you see some of the biases that are embedded into how we approach things. So that's one of the things we have to change. Also, as we look at these portfolios, these systems, we need to look at how to put them together, not from an optimum perspective, but from a robust perspective. How do we get robust solutions? And you know, rainwater, stormwater management in urban areas. So how do we take this green infrastructure, for example, combine it with the some of the traditional infrastructure, and develop an approach to practice so that we can make these decisions in an efficient fashion. We're progressing on these things, though. Water management, again, resource efficiency, both from a moral perspective, but from a practical perspective of realizing that we are going to be faced with a more turbulent future in term, from an economic and the availability of resources and so forth. So we got to think differently. Got to think out of the box. One of the options that, in fact, here at the University of Michigan and other places, but here at Michigan, we're looking at is the idea of source separation, separating gray water, which is relatively uncontaminated, the organic material in black water and kitchen waste, and especially the nutrients, which are largely in the yellow water, which is less than 1% of the total volume. So it's interesting the technologies that you look at. So one of the key technologies here is the source separating toilet. So this leads us into not only the traditional technical, but looking at how we interface with people, not only physically, but from a perception perspective and so forth. Again, we're working on these things. So we know how to do these. We know how to achieve these things. I'm talking about 2 out of 3. I'm going to come back to the third in a minute. So the first is to not put the blinders on, but let's consider all the options, select the best ones for each case. So the water professional really needs to have a working knowledge of all the different things that can be done. Don't have to be an expert, but at least a working knowledge. We put those together then in systems. So we're actually, when we compare alternatives, we're comparing alternative systems, some components of which are centralized, some components of which will be more decentralized, depending on economies of scale. So here's a little bit of an illustration. This is my artwork, but putting a number of these things together. Most communities won't have everything, but they'll have elements of this, again, to get that robust portfolio, both in terms of stormwater, water supply, and wastewater management. So the third thing is the human right to water and sanitation, which was declared by the UN. The U.S. is actually part of the UN. There's a tendency for many to think that, well, this applies to the developing world, but this applies to us. I've just listed here as an introduction to this the reference to the declaration itself. So here's a U.S. perspective by too many that this is about the developing world. It's actually much more significant. About half of the population lacks safe water, and 80% lack proper waste management. We hear about 2.6 billion that lack sanitation. That's a toilet. 2.6 billion lack toilets. It's not that the material is properly managed. So we've got a big job here. And the Sustainable Development Goals are helping us to focus on that. But the human right to water and sanitation has multiple dimensions. This is a diagram out of the IWA manual on translating what this means from a utility perspective. And what's shown here is an assessment tool to look at how in a given locality the human right is actually being satisfied. So it's not just about quantity and quality. It's about affordability and availability and equity and non-discrimination. And, living 50 miles from Flint, and Flint isn't the only one, but, in the U.S., this is something we really need to take on and address. So in my mind, 3 things we need to do: change water management, become more resource efficient, and actually take this human right to water and sanitation. Rights and responsibilities. Right doesn't mean you get it for free. Rights and responsibilities are linked, but we have to think about this in a broader fashion. So we've got a lot to do. So how do we do it? How do we accelerate change? And now we're really moving into realms of social science, because the change process is a social process. We as water professionals, how do we take these things and convert them into practices that are universally applied? And I'll conclude making some comments about leadership. So understanding and accelerating the innovation process, the S-curve of adoption, classic. It's a body of study coming basically out of sociology, but now well established in the social sciences. You see the classic reference there. This S-curve, of course, is actually in the up until you get the second inflection point where it starts to level off. This is an exponential curve. So this is an exponential process. The labels and really descriptors of different kinds of people is the important thing here, though. Understanding that different kinds of people react to new ideas and have a different willingness and motivation to adopt new things. So as we talk to potential adopters, we need to understand where they fall on this range of just personality types, and it affects how we talk to them. Well, the innovators, these are people that just like new things. They're important because they will help you to get your first applications of whatever it is. So I'm not talking just about products, it's any kind of an innovation. But by the number of installations or the number of uses of this, you can see that this is a very small part of the population. Point number 1, this is like 2 or 3%. So unless you are talking to 200 or 300 people, more likely 1,000, or unless you are talking to hundreds of utilities, you're not going to find, statistically, you're not going to find an innovator. This is a rare breed. Now these folks, they like the features, they like the new ideas. The next group, which is also a relatively small group, are the early adopters. These folks are aggressive in terms of adopting new things, but they adopt because it gives them an advantage. So in the terminology that's used, innovators, you can talk to them about the features, which is, if you're the developer of the idea, you love the features. When you start talking to an early adopter, you need to talk about the benefits, what it can do for them. So you have to change your vocabulary. Once you get the early adopters, then it's a matter just of the process moving forward. But again, this is maybe 15% of the total population. So don't get discouraged if most people won't talk to you. It is just the nature of it. Seek out those innovators and early adopters. This S-curve, these are just some examples. I could put up many. These are directly from the literature, but just show that this S-curve applies to water, just like anything else. There are even more examples of this that will be coming into the literature pretty quickly. Now, if you are looking to introduce a new idea, the most important thing is to get someone to use it. It is not a matter of getting it deployed in its in its best fashion. And I'll describe why in a minute, but get someone using it. And oftentimes, this is a niche application, and it replaces an existing unit, even if long-term it can be transformational, because people in general, can't envision something which is transformational. IBM, in the time frame that personal computers were first being considered, did a market study, and their conclusion was that it was stupid to think about investing in them because there would only be a market for them of about 100. IBM's, there's some pretty smart people there, but it reflects, again, this is just a human characteristic. So you want any place you can get it applied, you get someone start using it, because everything goes through a learning curve. Now I'm going to show you some data from the energy side of things, because this is one of the areas where it's been best documented. But everything goes through a learning curve. It gets better and better and better as you do it. So here's an example, but this is really classic in terms of expressing the performance. Now this is cost performance, but it can be performance expressed in numerous ways as a function of cumulative use, not time, but cumulative use. And you can see this is also an exponential process. So with a period of rapid improvement, but then even when something becomes standard, there's ongoing improvement in it. So you can be talking about an order of magnitude over a period of time. That's why you want to get your new thing in someone using it, so you can start running down this curve. And as it gets better, there'll be more and more places where people see advantage in it. This is the process, and things compete. They find their niches over time, and that's just really, again, from energy to illustrate the basic concept here. That's how it works. So that's the innovation process. How you talk to people, finding the right people, get it out there, get it used, and then ride the learning curve. Adapting practices. This is about how we and some suggestions about some of the different ways of thinking and acting by we as professionals. The first is dealing with the topic of risk. Because I tell you, as some of you know, I know Mazdak knows, I've been a change agent throughout my whole career. As soon as there's a new idea, there's someone that says, well, who's going to take the risk? And sometimes if they want to end the conversation, they kind of say it like this: who's going to take the risk? Make it sound like this big, hard thing. And it suggests that if we just do what we've done in the past, that there's no risk. That is false. And the second thing is, actually no one should take the risk. You should manage risk. That's what we do all the time with the things that we normally do. Risk management is and risk management techniques are something which are actually widely developed and widely available. You do it through a risk and opportunity analysis. So this is just outlining it, but a risk and opportunity analysis is simply just, let's make a list of all those things, plus and minus, that can happen. Let's think about the probability and the impact. So it's looking at the combination of how likely this is to happen and what the impact is. So a high probability, high impact thing is something that we really need to pay attention to. But then mitigation. What can I do about it? What can I do about it? If I can do something if this occurs, then it's a matter simply of cost and other practical matters. You turn this into something that we can deal with. And the techniques for this then, again, are well established. They're fatal flaws. A fatal flaw is an important risk that cannot be mitigated. Quite frankly, though, what you find is if you ask the question about mitigation, you find that there's usually something you can do no matter what. You can judge whether you want to experience that, but now it's a factual discussion. If you look at then, for example, costing, what you actually want to do is to look at this from a probability perspective. Monte Carlo analysis works very well for this. If you're in the construction business, you do this all the time. The little diagram there is oftentimes those things that we are comfortable with, we're more comfortable looking at the cost from a 50 percentile perspective. New things, we actually start maybe looking at a 90 percentile perspective. We conclude that they're not advantageous just because we have a bias there. Implementation plan then, when you elect to do one of these new things, understanding the things that you should be concerned about allows you to put together an implementation plan and mitigate many of those risks and seize those opportunities. This is standard, but it is how we should be looking at this and looking at the relative risks and how they could be managed, not only for the new thing, but for its conventional alternative. It's about the difference, not about the absolutes for either one. We're put in place infrastructure. This infrastructure has a long life. Why don't we think about, when we put infrastructure in place, how putting in place infrastructure that can be adapted to future circumstances? That's this idea here, and really trying to show you that it's the structures many times that have the long life. And actually, as many of you know, I've worked a lot in the treatment side, and you can actually put in place treatment facilities that can be adapted to different purposes, as long as you think about it. I won't take the time, but this is a real world practical example of being able to put in place an underground treatment plant that could be converted from, and you're seeing one example of conversion, to a membrane bioreactor. This was a thought process we went through maybe 15 years ago. So look at not only not look at infrastructure that's absolutely optimized to its current function, but will perform well for its current function, but can be adapted to future uses. We do this all the time with our legacy systems. So just some examples, some words here to support that, but we do that all the time with our existing systems. All we have to do is, rather than leave the current labels, back off and look, well, what do we have? Well, I have a pipe or I have a tank. How can I use it differently? And here's where the creative engineering comes in. Water service, we're looking at increasingly looking at the triple bottom line: environmental, social, and economic. And this is a really great, this is really a great step forward for us. But I would like to suggest that as we talk to people, as we think about this triple bottom line, that we actually think about the range of things that people care about. What you see here on the right-hand side, many of you will recognize this. It's the hierarchy, right? Maslow's hierarchy in terms of human needs. Oftentimes, when we talk about water, we talk about it only at the base level, or maybe the physiological and the safety level. People love water. People find water inspiring. So why don't we talk about that more often with people? It's very interesting. Another example from the International Water Association, but as the IWA in its Cities of the Future and some of the scholarship that supports it has the idea of a progression of water in cities, and you see the functions on the bottom, but how that relates to people, going from basic services up to intergenerational equity and so forth in the water sensitive city. This is really capturing Maslow's hierarchy from a water perspective. If we talk about the inspirational side of water along with the basic side, I think we can get much more support from the public. The change process, this is some very interesting work by Rebecca Brown at Monash University, and I just want to mention it and commend it to you. But you see again what looks like an S-curve, an exponential curve, but this is the progression of discussions that occur when you start with a new idea, and Rebecca Brown and her students, their work shows that at any point in time, as the conversation progresses and actions progress, you have those who are advocates and those who are more conservative. So you have advocating and contesting narratives. When I saw this, I look at the number of times I've lived through this dialogue. It's important to understand that it's just part of the process. It'd be a whole nother lecture, but then they've taken these 6 steps, looked at the actors in terms of accelerating it, the bridging institutions that can help the actors actually interact, and the building of first knowledge and then institutions that support this. So we understand the process. We understand the process in terms of making these changes. It takes time. It takes time, so we better be doing it now. Something's going to take time, we better start early. Our approaches to planning, as we move from instances where we have low uncertainty and need to learn little, as we move to having higher and higher uncertainty, and really in terms of significant opportunities to learn. And when you're doing new things, learning is really critical. This is moving to an adaptive approach to planning and then implementing our infrastructure. Again, I just want to mention it's a whole discussion, but moving from an optimal plan to a robust plan. A robust plan is not about simply minimizing costs or maximizing obvious benefits. It's about having options built into it. And again, we're learning how to do these things. How do you make these changes? Leadership is a key. It's leaders that actually take it upon themselves to see the things that need to be done and build coalitions. So it's interesting. I talk to a lot of young people. They want to do policy, and they believe that change occurs by someone issuing edicts. Change occurs from a bottom-up perspective, and it's people stepping up to be leaders. This is a learned skill. I actually have, going back about 20 years in my career, had an instance where we realized that leadership was the essential skill for a group of people, not management. And I learned that leadership is actually a learned skill. This is my favorite book on it by Kozis and Posner, but there's really just 5 things that you need to do to be a leader. First of all, you have to model the way. You have to be doing it yourself, set the example, inspire a shared vision. And to many engineers, as soon as you say inspire, they say, well, I can't do that. One of the points they make is if you have an inspired vision, you just need to clearly describe it. So anyone could do this. Challenge the process. So the process is set up for the old way. We have to change it. You need to be strategic. Pick where you can make changes, and as you make changes, the next level of change gets easier. Enable others to act. Help others to not only be inspired, but equip them with the tools to be able to adopt these new ways, and encourage the heart. Celebrate your successes. Interestingly, Kozas and Posner, they found that credibility was also an important characteristic of leaders. So they went and studied that. These are two different books that are each about 2 inches thick. But to be credible is actually pretty simple. You see the 4 items that they came to: honest, forward-looking, inspiring, and competent. Who wouldn't want to be a person like that? Another model for it's basically the same thing. It's about that vision, but developing a group of collaborators to move things forward. The same idea coming from a different perspective. So that's how we move forward. I'm a great Yogi Berra fan, not Yogi Berra, Bear, but Yogi Berra. So my concluding comments come from Yogi Berra-isms. Yogi Berra once says, "You've got to be very careful if you don't know where you're going, because you might not get there." We know where we need to go. We need to be moving in that direction in a purposeful way. Here's one I really love. Yogi Berra said, in theory, there's no difference between theory and practice. In practice, there is. So we need to have the knowledge, but we need to move this into practice, which is about going out there and doing it and learning by doing, running down that learning curve that I described. The game isn't over until it's over. That's the good news for us. We're never done in water. We just need to keep at it here. So with that, I'd be happy to take any questions and comments that you have. Thanks very much.
Thank you, Dr. Daigger. That was great. I think we could all use a little daily Yogi Berra affirmations for our calendars or something. We did have one question that popped up from David. I'm going to try and unmute him and see if he's comfortable and able to ask himself. David, can you try giving us a shout?
Sure. How is this?
Great. We can hear you.
Terrific. Glenn, thank you. This was a great presentation. I had a question, and maybe it's a little bit of decimal dust, but on your slides that showed how experience reduces cost in the electricity space, the lines on your graphs were labeled with a term you called learning rate. And I just wanted to know how that was measured, what the dimensions are. Is that simply some version of slope of that line? Can you talk to us a bit about that? It was very interesting.
Yes, while I speak, I'll see if I can get back to that. But basically, it's that was a semi-log plot, right? And
right.
So it's this one here. So it is simply the slope of that line, if you will, I mean, 20% is. I mean, so you could actually calculate a slope of that line, and it would give you the exponent in an exponential expression. Yes. What they're really trying to show here is that just make the point that the learning rate will be higher at initially, but decreasing. But if you took that 20%, this would be 20% per per megawatt or something like that.
Right. Makes sense. Thank you. It's a measure of elasticity almost. I get it. Thank you.
Yep.
Okay, I might just give it a minute or two here. If you guys have any questions or comments, you can either raise your hand or you can enter your question or comment in the little chat queue, and I'll be sure that it gets relayed to Dr. Daigger.
I might, while folks are thinking, I might, if you go back to this idea of an exponential, that things happen exponentially. Uh, it's interesting how you run across those ideas. Uh, Many years ago, I took a short course on innovation and technology commercialization. It was a couple of business professors, and one of them said, "Nothing in nature is born large. It's about how it grows. But new things grow exponentially. Think about a baby. Think about anything like that, right?" So I come back to this because this is an exponential curve. What, when something surprises us, why does it surprise us? Because if your perspective is in the information that you have, the data that you have is in the time frame here of the innovator, you've got some data and some scatter. The natural inclination of many of us is to put a line through it. So we think this is not happening very fast. And then we get surprised when that inflection point occurs. Well, it's because we're applying a linear model to a nonlinear process. There are folks that look at these things. They say, no, no, no. What you do is don't plot this on a assuming a linear model. Simply plot your data on a semi-log plot. It's about finding out what that exponent is in the exponential process. David, your question prompted me to say this because it's exactly the same idea, right? These things are exponential. So if you plot them on a semi-log plot, you then get a straight line. So the where I ran across this idea was in someone talking about, well, how do you get a sense of where that inflection point is? Well, you take the data that you have, you plot it on a semi-log plot that gives you the growth rate, and then you can come back and plot that on in a linear fashion. It starts to give you an idea when this thing is going to become material. Very useful information, very simple math that everybody on this call knows, but a very useful way to think about things. And as I've had some things like that, it really changes how I think about things. When you're looking at change, you look at the margins. You don't look at the central tendency. You look at the margins, and then look at look at where things are changing. And if you want data plotted on a semi-log plot, if you want it to move faster, it's how do you make that semi-log plot steeper.
Great. Well, we've had a couple more thought-provoking questions come up, hoping that you might be able to elaborate a little bit more on some of the institutional barriers and societal obstacles to change. I'm going to try and unmute Jessica Bolson. She's part of our stakeholder advisory committee, and see if she can spark some more insight here. Jess, can you give it a try?
Hi, yeah, sure. Thank you. That was so interesting, and I've been reading a lot about some of the things you talked about and been thinking about this stuff a lot. And so I totally appreciate where you were coming from with the policy not being the driver for change necessarily. But I was just curious about, your views on the different institutional barriers to one water approaches that have been documented.
So they are absolutely there. Anytime you're looking to do something different, those barriers will exist because the institutions, the practices, all those things that have evolved, they've evolved to meet the things that we've done in the past. They are so they will absolutely not be adapted to the new things that we want to do. It's just by the nature of how they develop. So, so the I've I'll be direct in my comment here. I hear so many people say, "Well, this is, this is the problem." It's the situation. If you're looking to do something new, there will be institutional barriers and so forth. I believe the process again kind of comes back. I've leaving this this S curve. The innovators and the early adopters find ways around things. So I believe the process is to create some of those initial positive examples so that people can see the benefits, start to see not just intellectually, but in real life, the benefits of the alternate approach. And the innovators and early adopters, in spite of the institutional barriers and so forth, they figure out how to get around them. Once you start to be able to demonstrate that that these new approaches are beneficial, then you're ready to have a dialogue about how to change the institutions and so forth. So the problem of trying to change the institutions first is you're now talking with a much broader range of people. You're talking with people more in the middle of this who are much more change unfriendly. So this is I'm going to the work of Rebecca Brown, and it's really folks like that. So this is an expression of the process as well, and it's interesting when you if you look at tools on the right-hand side of this table. In the initial phases, the tools, well, she's got NA. This is just people starting to go out and do things and so forth. You start and you draft best practice guidelines and targets. It's as evidence starts to develop that you actually start you actually have a basis for changing the institutions and the practices and so forth. This work is based on actually looking at changes in water management in Australia. So this is based on how change has truly occurred in real world settings. So so what I'm saying is logic like this and research like this suggests that you don't start by trying to change the institutions. You don't have the basis to be able to do that from a social perspective, so to speak. Focus first on creating some successful examples. And to do that, you have to find that small number of people that are just motivated to and determined to do new things. As you do that, then you create the basis to turn this into something which is done more regularly. So you're putting in place the institutional changes, or the institutions and the changes in practices and so forth. So the institutional barriers are going to be there. It's about circumventing them initially, and then as the evidence develops for people, then it's a matter of then having a basis to be able to make those changes. That's how I've come to look at this.
Great, thanks. Jess, you're still unmuted if you have any follow-up questions. Seeing a question or comment from Ed Clerico. Let me see if I can unmute you. Edward, are you there?
I'm here. Can you hear me?
We sure can. Take it away.
Hey, Glenn. Nice to hear you.
Good to hear from you, my friend.
My question relates to the graph you had up just a second ago. If you don't mind putting it back up again. Not
Okay,
quite clear. Sorry.
This one or
No, the one with the social change. There you go.
Yep.
This to me, mimics what happens with the introduction to a market of any new product or business as it's introduced and launched and then grows and then matures. But in this illustration, the information, the social process you're referring to, is that all focused on institutional social process? Or are you actually illustrating what you believe is the shift in the social norm around individual thinking?
The individual thinking is absolutely the lead. So the institutional part of it comes after the fact. If I'm understanding your question here. So this is about if you kind of there's a version of this where people show the distribution of numbers of people in these different categories, and the innovators and early adopters are the innovators are like 2 or 3%, and the early adopters are like 5 to 10%. So these are really small fractions of the population. So that's why people that unless you're talking to a large number of folks or know who the innovators and early adopters are, the people, good-hearted people, but if you're talking more to the middle, you conclude that no one is ever going to do anything new. It's about finding those folks at the margin, in a sense, the innovators and early adopters, to get those initial successes. So that part of it is about the people, and then the second part of this about people is that, and when I say people, it's also organizations. So organizations have these characteristics. So from a people perspective, there will be a relatively understandable progression in terms of who adopts things as this progresses. As that occurs, then people start doing things differently and so forth. So then the practices and the institutions and all that kind of stuff adapts and is adapted as we move forward. Why do we have institutions? Why do we have practices? It's to be able to efficiently and in the easiest fashion replicate things that we want to do, right? That's why we have those things. So they actually, I'm positing, and I absolutely believe that those changes follow the change of behavior. They don't lead the change of behavior. Am I answering your question?
You are, but we probably could have a long conversation about that. This is probably not the place for that, but I think there's a distinction here between the water industry and how institutions control it, and what barriers are created by the institutions themselves to advancing innovation that you wouldn't find in a more free marketplace where the general population is sold something, is convinced that something's good. I think in many cases here, the institutions themselves, for various reasons, prohibit that. And I'm just wondering in this curve, if it's thinking mostly about the institutions or if it's thinking about the general population, or if you see a relationship between those that might be different than this curve.
I see so when I look at this, I I think about this in terms of individuals. I also think about this in terms of water utilities. I think about this in terms of communities and so forth. So now, as soon as you start talking about institutions, then institutional issues then become part of this as well. So I think about it. I do think about it as actors, but you could think about this in terms of regulators that are operating within a system and a structure. So I am thinking about it more so about actors. I think that's a better term for it. So it could be people, it could be interest groups, it could be individual institutions and so forth. Yeah, I think this applies most directly to actors if you adopt that broader definition.
Okay, thanks.
So you met my friend Ed. You met my friend Nancy and over in Switzerland, huh?
I did. This is a very timely topic. Thank you for doing such a great job representing it.
Yeah. No, I'm happy that they met you.
Great. Well, this was a really fruitful discussion this afternoon. Hey, Glenn, we did get a request that if there's any way possible, if we could make the slides available, either as a PDF or send them directly to the requester. If you're open to that, I'd be happy to get those in the right hands.
Yep, I'll forward a PDF to you, Sarah. So you'll know what to do with them better than me.
You got it. Wonderful. Well, Glenn, thank you for your time today. Thank you to everyone who joined. We had about 33 people on this afternoon, which is a great turnout. Please be sure to tune in next week when we hear from Doug Yoder, Deputy Director of Miami-Dade Water and Sewer. Thanks for your time, everybody. Have a wonderful afternoon. Thank you, Glenn.
Okay, thank you.